Hi, everyone, and welcome. We really appreciate you being here today, and I hope you get valuable information about evaluating NLP tools during this webinar. I'm going to be your moderator, and I'm going to make sure all your questions are answered. I'm sure you've already noticed, but everyone's muted, so if you have questions anytime during the presentation, feel free to ask them throughout, but we will wait until the end to answer them. To submit a question, just click on the Q&A button at the bottom of your screen. Now, when the webinar ends, you'll be directed to a survey. We would really love it and appreciate it if you could take 1 minute to just let us know your opinion. It really helps us out, and we're planning more webinars, so we just want to give you the most value we can, and your feedback is really helpful to that. The webinar is being recorded, as mentioned, and we're going to email the link out tomorrow to everyone who registered. So if you find it useful and informative, please feel free to share it with anyone who you think might be interested. While we wait for a few more people to join, I'm going to spend just 2 minutes telling you about Basis Technology and Rosette. Basis Technology has been around for 25 years, and our mission has been focused on getting structure and meaning from unstructured text. And Rosette is our text analytics brand. We pride ourselves with providing a high quality, carefully curated, and tested set of text analytics and natural language processing capabilities. So testing and evaluation of NLP has become one of our in-house specialties, and it's a service we provide to customers. And this is what inspired Gil's talk today. So if you want to read more after this talk, there's also a How to Evaluate NLP series on our blog. So you can check that out at rosette.com/blog. We also pride ourselves with comprehensive NLP coverage. So this includes both breadth of capabilities and in language support. Rosette enables high quality analytics in over 32 languages. Now, all the Rosette capabilities are highly adaptable with easy tools for domain adaptation and have many options for deployment. So we work with our clients to engineer the best possible NLP solution for their needs, using every possible data source to make their AI smart and resilient. So major brands that you know deploy Rosette on-premise and in the cloud for their mission-critical high-volume systems. So that's all I'm going to say about Rosette and Basis Technology. So let's kick this off. This webinar is planned for 60 minutes. There's going to be a 40-minute presentation followed by 15 to 20 minutes of Q&A. Before we begin, let me introduce ourselves. I'm Allie Devine. I'm the event manager here at Basis Technology. I'm based out of the Cambridge, Massachusetts office, but I'm currently transmitting to you live from my basement office, where today I'm pretending is these beautiful mountains behind me. And since I know you don't want to hear about evaluating NLP from me, let me introduce your host for today's talk. Gil Irizarry is Basis Technology's Vice President of Engineering. He's worked at Basis for 6 years and has a background in computer science and project management. Some fun facts about Gil: he competed in the first annual Boston Crossword Tournament, where he came 8th out of 34, which is pretty awesome. And I just found out yesterday he's a 3rd-degree black belt in Taekwondo, so I'm not going to mess with Gil anymore. So Gil, take it away.
Thank you, Ellie, and thank you everyone for attending. I hope you'll get some useful information. And as Ellie mentioned, we love questions. Feel free to ask questions and we'll get to them at the end. Just an overview of what we're going to discuss. We want to understand how do you evaluate NLP tools. So we'll look a bit about what the actual problem is, how you define the domain, getting test data, and most importantly, how to annotate the test data. Then an overview of different types of measurements, some measurement examples, and then wrap up towards how we put it all together. So as Ali mentioned, Basis produces text analytics software. Just want to tell you a little about our capabilities. So we provide a full NLP stack from base linguistics to morphology, to entity extraction, to entity linking, sentiment and text vector capability. We have name matching, name translation. Not listed here, but our new development includes full web applications for better text annotation and identity resolution. Now, at the base of all this is evaluation. We are often asked how do we rank against some other product, be it a commercial product or open source? And even ourselves internally, how do we rank our own software, and how do we know if a change we're going to make to the software actually improves the software or not? These are common problems, and probably problems that you run into also. So we want to talk about how we attack that problem and the methods for identifying improvements. So what is the problem? You've got some text you want to analyze. How do you pick a tool for analyzing the text? Or if a tool is given to you, how do you know how well the tool is doing? And there's a related question. So I've got annotators who are annotating text. How do I know if they're doing a good job? And you'll see here that in many ways these questions are interrelated, and the way that we assess the answer to one affects the way we assess the answer to another. But these are not straightforward questions. You would think that we just take some text, run it through both tools, look at the output, see which ones missed what we're interested in, and then we call it a day. But it's not that simple. The tools themselves output different formats. They analyze data differently. They extract different kinds of entities. And they just not only work differently, they expect different input. And then the data that we ourselves are putting in may have been annotated differently among different annotators. So what we need to do is define a problem space. Now, what I wanted to do is highlight the complexity here. So here's a bit of sample text, and here is some Rosette output. And as an example, here's Amazon's Comprehend. I could have picked any tool, but Comprehend is really simple to set up and easy to get some output. But there are a lot of NLP open source tools and commercial tools that do fairly equivalent things. But I did want to highlight some of the differences. So Amazon's UI color-coded green for the person entities, Rosette colored it as red. So you'll see the names came out the same. But Rosette identified a pronoun, and Comprehend didn't. Now, Comprehend identified some titles, but it missed some others. But the green here is meant to highlight a person entity. And so CEO was not extracted, but it was identified as a person, no different than Travis Kalanick. Now, Rosette identified titles, and it identified them as a different type of entity than person and organization, which is good. But it also identified Vogue editor as a single entity versus Comprehend more appropriately identified Vogue as an organization. And even though it didn't identify editor, it didn't merge the two together. So this is not to say either of these are right or wrong or one's better than the other. You can decide which you like better, but to highlight that we can't just put them next to each other and say, I have a winner, but we need to find some method of evaluation. So, of course, what we need to do is identify a set of input text that we are going to give to the tools. And first, we need to evaluate what is our domain. What domain are we in? And this is important because the tools themselves are models, whether they're statistical models, whether they're a rules engine, or even a neural model, they're trained on a domain. And you can either pick text that fits the domain that the tool is built in, or you can pick text in the domain that's more germane to you. So very often tools are built on general text domains, and you can decide if you want to grab news text, which, this example before very much is just general news. The tools did quite well. Are you in the legal office? Are you scanning patents? Do you want to give a set of patents? Are you looking for financial fraud? So you get text from the more fintech domain. Very popular right now is a medical field. Are you looking at medical records? Identifying the domain is important because, of course, the next step is you've got to identify a test set. How do you pick the test set? Of course, it depends on the problem that you're trying to look at. So do you go with a general set of text? Do you go with specific text? And then, since many of the models are based on a particular domain, they often have the capability of allowing you to train a custom model. Do you train a custom model because you want to evaluate that model on a domain that you're interested in? For example, when I spun up Amazon Comprehend, it actually had a special purpose-built medical model because that's a hot area these days. You'll see a lot of medical models. So do I use the medical model because I want to evaluate on medical text? Rosette, for example, allows you to train custom models. So do you go through the effort of actually getting domain-specific data, annotating it, then building the custom model and evaluating against that? These are decisions you want to make up front. And once you've got a set of text, you've got to basically declare your gold standard. What is it that you're measuring against? Now, in the example I showed before, I basically said, well, there is no gold standard. I didn't decide if we want to extract pronouns or not. But when you're doing evaluation, of course, this is very important. So here's some questions to illustrate, what would an annotation guideline look like? So Alice shook Brenda's hand when she entered the meeting. So when we extract Brenda, are we dropping the possessive or not? So is it Brenda that we extract, or is it Brenda's? Similarly, the pronoun, do we extract she at all? And if we extract she, does it matter that we resolve she back to Brenda? Punctuation. So some models may use punctuation, for example, a period to indicate the end of a sentence. Now, punctuation is changing, and it changes over time, and it continues to change. So if you read the New York Times tries to adhere to the traditional standard where UN and US have periods, right? Because they are abbreviations. But commonly, people today are dropping the periods, and so you'll see UN written without punctuation. If you're grabbing a news source from a formal media organization, you're going to see the punctuation. Are they to be treated the same? You may say yes, of course, obviously. But maybe the tool doesn't, and will you define the difference in behavior as a problem or not? Harry Potter. Is Harry Potter a person? Okay, so fictitious characters, made-up names, historical characters. So Uncle Sam for the United States. If you were doing an analysis of the Harry Potter text and you wanted to find the relationship between the characters, certainly you want to extract Harry Potter. But again, if you're reading a news corpus, maybe you don't want fictitious characters entered in. It depends on the domain you're looking at, and then create the guidelines to match. Do you pull out location? So San Francisco Association of Realtors. So is San Francisco a location to be separately identified, or is that an overall organization? Similarly, Martin Luther King Day. So Martin Luther King Jr. as a person, do we extract him separately from the holiday? And you run into these sort of embedded names all the time. Twitterverse. Twitter is an organization, it's a corporation. Do we extract Twitter out of Twitterverse? And if someone says, I Googled it, do we take Google out? Then naming. So names change over time. So once upon a time, we used to refer to Ukraine as the Ukraine and the Sudan. So that generally has been dropped, but in my corpus, I may still find that the Ukraine is listed. Do I extract the? Do I keep that article, and then do I resolve it to be the same as Ukraine? And similarly for the New York Times, when I have the New York Times was criticized for an article in the edition of the New York Times, well, one's an organization, one's a product. So is it important to call them out separately? And then, this is a classic example with NLP. Washington and Moscow continued the negotiations. So are Washington and Moscow specifically locations there or organizations? Now, in no way do I want to put out an opinion as to what the right or wrong answer is, but how you define your standard will decide what you consider to be the right or wrong answer. And since the talk is focused on entity extraction, those were very much entity extraction examples, but if you're not doing entity extraction, the questions still arise. So I've got multiple sentiment analysis tools. Each one maybe puts out different levels of sentiment. What are the levels that you're looking for? Can you map levels, one set of levels to another? Ontology and classification. So if you're doing text categorization, what is the ontology that you're mapping to and that you expect the tool to map to? Language identification is one of the most basic NLP operations, but it actually can get very complicated. So there are countries that have political boundaries, ethnic boundaries, languages sort of deviate over time, dialects start to form. Are they different languages? The Middle East, you find Arabic widespread, but there are regional differences. Egyptian Arabic sounds a little different than Lebanese Arabic. Then there's the case of macro languages. So we refer to Norwegian as a macro language because it's made up of Bokmal and Norsk. Do you identify them separately, and do they roll up to the macro language, or are they completely separate languages? So what you want is to be able to map these to known entities. You want to be able to map levels of sentiment. And you want to, if you've got multiple categories, you want to map one set of categories to another so that if a tool has 5 levels of sentiment and another tool has 3, can you collapse the 5 levels to 3 levels so that there's some meaningful correspondence? So I want to show here, this is a screenshot of the table of contents of one of our annotation guidelines. So this is the entity extraction annotation guidelines for all entity types. And you'll see here, it's 42 pages long. And when we bring on an annotator, we give them this document. And this tells them, this is what we expect annotation to look like. This is how we want our documents annotated. And I'll tell you that this is only one of our annotation guidelines because this is for all, as in all languages. We've got language-specific documentation because there are specific language rules about the way you deal with particles in Korean and the way you deal with gender in Russian names, right? So in addition to having documents for the other NLP functionality we've got sub-documents by language. We've got probably hundreds of pages of annotation guidelines. And if I can tell you what is the most important slide in this entire talk, it's this slide right here. The annotation guidelines are probably our most important documents because they decide how we define the gold standard and then how we measure the tools, right? They also decide how our annotators work within docs and then how we measure the annotators against each other. So it's very common, we'll be in meetings and we will have lots of information, in fact, meetings where people require clearance. And all of our information is pretty much available and publicly available, except when we get to the annotation guidelines, when the annotation guidelines themselves are under NDA, because the annotation guidelines are really that important. And I encourage everyone listening to this to make sure that you give your annotation guidelines the importance that they need. And basically, you'll see that the structure of this talk is to put all the questions up front, because I think that the thing you wouldn't want to do is get some text, throw it at a tool, and start looking at the output of the tool. To do a good evaluation means to do good planning. And it's on purpose that the flow of the talk is, define your domain, get some text, establish annotation guidelines, and then annotate. Then once you do all that, then you can run the tool, and then you can start worrying about measurement. And so here I wanted to list some standards, not so much related to entity extraction, but if you're doing morphology, you want to think about universal dependencies as a common set of part of speech tagging that you point to, DB ontology for a common ontology that you can point to and have tools map to. Wikidata provides great set of entities and entity IDs for linking. So again, a common database for what an entity name should look like and how to take multiple entities or multiple spellings of an entity and have them resolve to be the same entity. So when you can map to a known standard. So having established our guidelines, having set up our goal data, I want to review quickly how might we go about to do the actual measurement. So first, again, the bread and butter of this kind of measurement is precision recall. I think everyone knows this, so I won't spend too much time on it. But precision is the set of documents returned over that are positive over the full set of documents returned, right? So the amount of false positives here is very important. And intuitively, you can understand, I can have perfect precision if all I do is return one doc, but that one doc is correct. My precision is great because I'm guaranteed that that one doc is going to be correct. So as long as I have very few false positives, my precision will be very high. Now, contrast that with recall, where recall is the number of true positives over the number of overall positives in the domain. So I can have perfect recall very simply, literally return every answer, right? Because then my recall will be perfect. I'll have a lot of false positives, so my precision will be low, but my recall will be high. And again, intuitively, you can see use cases. So imagine I'm a very small bank. I care about fraud, but I don't have a large team. I care about precision. If my system tells me this is a fraudulent account, I need my team to only be focused on sort of guaranteed important work. So I want high precision, low recall. But we all come in contact with a system that has high recall and low precision, which is the airport, right? When we go through security, they are scanning literally everyone. They want that recall because they don't want to lose anything. And they probably are getting lots of false positives, but because they care so much about the domain of true positives, they're willing to tolerate many, many, many false negatives and occasional true positives. So we want to combine precision and recall into a single score. This is commonly called an F-score. It's important to know this is a harmonic mean between precision and recall. And a harmonic mean is not an average. And this comes from Wikipedia, as do all the other images. It's important to know what that means. And when I first learned this, I struggled a little bit to get an intuitive understanding. But see here that you have A and B. Imagine A is precision and B is recall. So in a straight average, if I increased A, the overall average would go up. That's very simple. But here, if I increased A, and imagine A brought it down here, this line here, and line G, would actually get smaller. This radius here would tune down, this perpendicular flip up, and H, the hypotenuse here, would actually get smaller, right? So as A increases and we get lower, this line gets lower, H is actually going to get smaller. So H is the largest when A and B are perfectly balanced. So, and this allows to have a single number that perfectly balances so that A and B, you can't overweight one or the other and allow it to feel like you're getting better when in reality you're not. So a perfect F-score would be a perfect balance between precision and recall. And the other thing to note is that the common F-score formula is actually a special case. There's a more generalized case where you actually have a beta term, because let's say you want to actually weight precision higher, or you want to weight recall higher. Well, you can actually adjust the beta term, and you can still get that harmonic mean, but you can have a weighted harmonic mean. So F-score, the commonly used F-score formula is actually an F1 because beta equals 1. You can have F2 and F0.5. So, you know, as you increase this number, you're increasing the denominator, which actually makes precision go down. So an F2 is actually higher recall, and then an F0.5 is a weighted higher precision. So those are the common measures. Kind of everyone uses them, but I do want to tell people about some other things if you don't already know them. So average precision and mean average precision. So precision and recall are basically single values, and they're values that are ratios. An F-score is a single scalar quantity of those ratios. But average precision is basically taking recall and precision over a set of results, not just a single result. And then mean average precision is averaging, or the mean basically, averaging out the average precision over a range of queries. And we'll see in a moment why that's important. There's also MUX scoring. So the Message Understanding Conference produces a set of scoring criteria. And the other thing, the main takeaway here is that in our previous example, either you were a true positive or a true negative or a false positive or false negative. With MUX scoring, you get credit for partial correctness, partial responses. And there are cases where you'd find that more important. And we're going to go through examples in a minute. So I'm about to go through examples, but we can only do an example if we actually have a gold standard. So the set of text I ran at the beginning, we're going to take that text and do some markup. So here's our text. And then now we've done some annotation. And I put in bold what's annotated. And so it's important to know the choices I've made. So we're only looking at people names. And we are looking at partial names, right? So Cook here refers to Tim Cook. The possessive is not included. Kalanick here refers to Travis Kalanick. Now, for the purpose of this example, we're not talking about entity linking, and we're not going to measure the linking of those names. But in my standards, I'm implying here that I do care, and if we had more time, I would show you how we would look into that. So very quickly, so imagine I do here some markup, and I've done some annotation coming out of a tool. So the orange is a false positive. So I said I only want people names, but my tool was too good, and olive is false positive. So it identified Emerson Collective as a person because it saw Emerson. Orange is true negative, so it didn't identify Vogue, Uber, and Apple, which is good. But you know what? This tool isn't so good. It only thinks that names have multiple tokens. Single names it left out. So those counted as false negatives. So looking at the formulas we went through before, this system, the imaginary system, has an F-score of 0.74. But if we want to do average precision, the way you do average precision is you're counting up your positives in order over the set of true positives. So we're going to go in order. So Tim Cook is correct, Anna Wintour is correct, Travis Kalanick is correct. So the first answer out of the first expected answer, that's 1 over 1, 2 over 2, 3 over 3. So the fourth correct answer should have been Cook, but that's a negative or false negative on our part. So we credit that with a 0. And then every other example is actually now fractional. So the misses count for a lot, and the accumulation of misses actually hurt you a lot. So you count up all the fractions, and then you divide by the positives you found, not the overall set of positives. So you come up with an average precision of 0.8. So, and before I get to the muck scoring, what is that mean average precision? So mean average precision, in every tool, there's going to be some confidence value. How did we know that this is Tim Cook? How did the tool know that Tim Cook is a person entity? So if we evaluate 0.88 for a particular confidence, then change the confidence, rerun the tool, get a different set of results, calculate average precision. Basically, if we can calculate average precision at each step value of confidence, then we can get the average precision over the entire range. We can have mean average precision basically be a number, a single number that gives us a sense of performance over the full range of results over that same text. Okay, and now muck scoring, basically very similar. We're going one by one here. They established a taxonomy for how you evaluate the token. So B is beginning. This is the beginning token of a person. Now here, just to make this very simple, I cut out only one sentence. But imagine there's here a gold standard on the top. Now the bottom is what the tool is doing. Again, some imaginary tool. It found Cook, but it identified Cook with the possessive, the apostrophe S. So we only get partial credit for that. And for whatever reason, it actually picked Cook's date as a full entity. And that doesn't match the gold standard. So we call that a spurious entity, right? So the entity types here didn't match between gold and eval. So imagine it did pick out jobs, but jobs was in the gold standard, the single jobs. Maybe our tool is really naive. It saw a line break, so it's separated. And so here the token was missing, or the token identification. So we had a person token, and B is beginning, I is intermediate. What should have been a follow-on token to this is counted as a missing token. Now imagine our tool, maybe it would have identified jobs, but it would have thought with the line break, this is a whole new token. And then that's an example here. It thought this is the beginning of a token, beginning of an entity, sorry, which is Apple. So token alignment is important, and we get, we can see the differences between spurious tokens and correct tokens, missing tokens. So the muck scoring identifies this sort of identification of tokens, and then from that there are formulas, and I'll let you look up the math, but they're very published formulas of how you calculate possible and actual values, and then they define their own precision and recall. And so you can see here between the correct and the partials over the actual, the correct and the partials over the possible, we can get precision recall. And then from those precision recall, we can actually just calculate our own F-score. So we can have a muck F-score separate from the more canonical or traditional F-score. So I did want to mention inter-annotator agreement because this comes up a lot. Now you might think, well, it's great that you talked about all of this gold standard stuff, but why does it really matter? Because I've heard there's this inter-annotator agreement score, and I can measure the output of tool A and the output of tool B. So I did want to say there are many different inter-annotator agreement scores. The two most common are Krippendorf's alpha and Cohen's kappa. Again, these are known formulas. You can look them up. Certain libraries will actually have automated calculation of Krippendorf's alpha. So I think it's NLTK, if I remember correctly. You can give it text and it will actually compute the alpha and the kappa scores automatically. But the important thing to know is that these tools, these scores were designed not between two sort of arbitrary, unstructured, they were designed to measure annotators. So they're designed actually for typically unstructured phenomena, not when there's some gold standard, right? So all it's going to do is tell me the agreement between annotator A and annotator B. We wouldn't want that between tool A and tool B, because that's not going to tell us which is best. And we certainly wouldn't want to use this for gold standard A and eval output B. That's not what it's really for. What it definitely is for is I've got multiple annotators, and let's say I've got annotator A, B, and C, and A and B have a very high score between each other, and then annotator C has a low score between A and B. I might infer that annotators A and B are probably doing a good job, and annotator B is not. Now, of course, annotator C could be doing a really great job, and A and B are doing a poor job. You have to go and look at the actual annotations that they're doing. But you can use these scores to kind of help you identify which of your annotators are not doing a great job. And you can use that to improve your gold standard annotation, right? So all of this is to get to that gold standard annotation. But I wouldn't want anyone to come away thinking, oh, inter-annotator agreement is an easy way for me to decide whether a tool is good or not. You really want to do something like mean average precision. So I do want to say, when at Basis we are doing calculations of mean average precision, we do calculation of mean average precision for every software release that we do. And very commonly, we even do it on a per code check-in basis. So we can decide if adding a new neural model or updating the input into a statistical model, if that's making the model better or not, because we're running mean average precision constantly. In fact, we keep a database of mean average precision scores so we can actually see the change over time. Now, you might think, oh, well, that sounds like a lot of calculation, but it's important because we need to know, how are the code changes affecting the performance of our system? And we center on mean average precision because it is the one number that gives you that sense across a range of results and across a range of input queries, right? So different queries, different tolerances, and different confidences, and then we come up with that one number that tells us how the model is doing. So to summarize, do the upfront work, and that involves define the requirements, define what is your domain, create a test set, scrape from the domain that you find important. And the corollary to that is find either the model that matches the domain or think about training the model. If you really care about medical data and your model is based on general news data, very likely your model is not going to perform very well. But that may or may not be a reason to reject that tool, right? If the tool is trainable and can apply to the domain, then that may be a reason to keep the tool, right? So trainability is important. But ultimately, you define the domain and find the tool, either the settings of the tool, the configuration of the tool, or train the tool to match. Annotate your gold standard. Think about all the annotation issues up front. And I will emphasize that we spend a lot of time on gathering data and annotating data. In many ways, we consider ourselves a data company as much as a tools company. And our annotation standards and the data we've collected are as important as the tools because the tools are built off that data. Get the output of the tool and define a way to evaluate the results. And I put up a few. There are definitely others. The most important thing is be consistent. Be consistent in the way you do your evaluation. Be consistent in the way you annotate the standards and the way you do the scoring. And then ultimately, you make a decision. So I think I've hit my time. I'm going to turn it back over to Allie, and hopefully we have some questions.
Great. Thank you so much, Gail. So yeah, now it's time to ask any questions you have. So click on the Q&A button on the bottom of your screen to submit your questions. Try to get them in early because I will try to group them together, similar questions. We do have a lot of people on today's webinar, well over 100. So if we don't get to all the questions today, please feel free to reach out to us. While we're waiting for some questions to come in, I do want to remind you that this presentation is recorded and a link is going to be emailed to everyone who signed up. So please share it if you enjoyed it. Also, if you are not able to stick around for the Q&A session, when you leave the webinar, you'll see a survey pop up. Again, please just take 1 minute to let us know your thoughts. Your feedback is so important to us and allows us to continue to improve the webinars that we're putting together. Speaking of, in 2 weeks, we have 2 webinars scheduled about name matching. On Tuesday, May 12th, it's a technical webinar from our R&D team called Understanding Names with Neural Networks. And on May 13th, we'll be hosting another webinar called Smart Matching for Screening, which is more of a high-level overview of how smart name matching is deployed in critical business systems. So you can find all the details about those and any other webinar we announce at basistech.com/events, or you can follow us on LinkedIn or Twitter, and we'll be announcing them there as well. So let's get to the questions. So we did get several questions on the annotation guidelines. So first question for annotation, are your annotation guidelines available to clients under NDA?
So yes, we have shown them to people, and if you are a partner, if you're under NDA or you're talking to our team, that can be arranged.
Great. Sorry, I'm just trying to get to the annotation ones specifically. How long does it typically take to write the annotation guidelines?
That's a great question. They have been built up over time as we run into new issues. And when we work with new languages and we gain experience in those languages, we sometimes make a language-specific set of guidelines. So our guidelines are the accumulation of years of knowledge. Now, I don't want to tell you it's going to take you years, but you'll get started and you'll think of basic questions, and then as you go, you'll learn more. So you certainly can, spend a good, week of writing guidelines, thinking about problems, maybe hunting in the web. But you will update them over time. But I can tell you that we've got years of experience built into ours.
Great. And Robert asked, does Rosette have private annotation sets similar to Wikidata that we as partners can all can test the sets together and use them together instead of having to build up from scratch by ourselves individually?
So we definitely have, we have our own training data sets, our own evaluation data sets. When we go gather data, we try to make sure that the training set and the evaluation set are in the same domain, but we do the right thing. We separate them out so that you're not, training on the eval data. But we do have these sets, and it's across entity type, it's across language, and for the NLP, right? So for our name matching, we're going to have gold standards of what name in this, language A matches the name in language B, versus the gold set for entity extraction, gold set for part of speech tagging. So we have lots of training data, we have lots of eval data. And again, talk to our team, and I'm sure that we can find a way to get NDA and share data with you if you're interested.
And Jennifer asked, what happens when you combine annotated data sets that were developed with different annotation tools?
So that is a very good question. It's a problem that you're going to run into. So, you know, we tend to think about the quality of annotation and quality of the annotators, but the annotators themselves could be working with different tools. Now, we at Basis, we employ lots of annotators. We have many people working in different languages, and they know the language. One of the things that we do is we give them the annotation tool, right? So to try to minimize that problem. But if you've got data that came in and it was annotated differently, you'll have to run some of the scoring to decide the quality of the data, quality of the annotation, and find some measure to decide which data you keep and which data either you throw away. Now, in our case, we don't throw away data, but we re-annotate data. If we decide that an annotator is doing a poor job or the tool is hindering the annotator, we'll go and employ more annotators and re-annotate until we get to a score that we think is acceptable.
And can you recommend an open source tool for capturing annotator annotations in a format that lends itself to calculating mean average precision?
That's a good question. So we used to use BRAT as everyone else does. It's an open source tool. I think it's the rapid annotation tool, and the B is just so they can make the acronym. So I mentioned very quickly at the beginning, we're working on our own annotation tool because we ran into the limitations of BRAT. And since doing that, we've come into other companies, come in contact with other companies that we found out are doing similar things. In our tool, we're calculating the inner annotator agreement sort of automatically and as the annotators go. So it's easier in our tool to have multiple projects, have multiple annotators on projects. And as the annotators are separately and independently annotating, the inter-annotator agreement is being calculated so that a project manager can go to the project and look at the scores, and it will do them across all annotators. So it'll produce a grid, every annotator to every other, so you can get a fairly clear sense of who's doing the right job or not. We didn't find a very easy tool. It's certainly not an open source one that did that. So that's why we went and started building our own. And since we've done that, we've seen actually quite a lot of interest from people who want that kind of functionality. I will tell you that if you hunt around, there are other commercial tools that also do that, but I haven't found an open source one that does.
And can you say any more about why inter-annotator agreement is a poor method for comparing a model output to a gold standard? High agreement with gold standard would seem to be a gold measure, no?
So I would just say that if you go read Krippendorf's paper, you'll find that he explicitly says, this is a measure between two things that are fairly equal. And when you have a gold standard versus an eval set, it's very unequal. One is right and one is wrong, right? Krippendorf's alpha is there's no right or wrong. I just want to measure this agreement between them. So sure, you could say, well, that agreement between the gold standard is exactly what I want. It's a naive application of the Krippendorf's alpha, and certainly not what the score was intended to do. Also, we heavily favor mean average precision because it's giving you scores over a range. Like, you don't want to calculate Krippendorf's alpha across every possible output because you're going to run multiple, get multiple outputs when you change the confidence level and see, you know, at different tolerances, some entities might pop up versus might go away. So mean average precision is going to average all of that and give you this one number that you can say, okay, across a whole range of output, this is the performance of my system, versus Krippendorf's alpha, where even if you used it sort of inappropriately, it still is going to be this one score. And then, you know, now where you're going to calculate an average of Krippendorf's alphas across all these ranges, now you're moving even further away from what the intent of the number was.
Okay, and to what extent does an annotation tool impact the precision and recall of tools trained on data annotated with the above tool?
So Ideally, the tool is transparent, right? What really matters is the annotation that the annotator is doing. And so the only reason we launched going into writing our own tool is because there was functionality that we thought BRAT was missing. But for the most part, BRAT was fairly transparent. Now, where you get into trouble is, I very quickly mentioned sort of entity extraction annotation versus entity linking annotation. If your tool doesn't allow you to sort of do these linkings and say, Steve Jobs, started his company, and then you can't tie his back to Steve Jobs. If your tool prevents you from doing that, then the entire quality of your annotation is going to suffer. If you thought that that's a thing that's important to you, right? If you define your standard either in a way that makes the tool a positive experience or in relation to the tool so that you pick it based on what the tool is doing, then you have no problem. In which case, then you want the tool to be as transparent as possible. If that's not possible based on your domain or the specific realm you're in, then you have a problem. Then you either need to find a new tool, or you need to sort of change your guidelines, or maybe post-process after your tool to do something. So we've tried to make things as tool agnostic as possible so that we don't run into that problem.
And can the annotator's call on Emerson Collective and error in first pass be put into the system to change the prior preference in future runs?
So given that example, and let me go back and share that screen. Okay, so if we're looking here, so the question is, this tool went and, in this made up example I have, it extracted Emerson Collective, and that's a false positive because it's not a people name. So sure, if what you want is that you have the tool learn, hey, I'm going to have some other tool where I click and highlight and I say, this is a new gold standard. You can certainly do that. You can try to say, I've updated my standard, so Emerson Collective from now on is a true positive. And, all the tools have this capability. I mean, Rosette certainly has the capability of adding to its knowledge base, adding to its list of entities that it looks at. And maybe we didn't extract Emerson Collective before, now we do, so the tool has learned. But I would caution, part of what we wanted to show here is not just the scoring in the example, but the gold standard. You certainly wouldn't want to change your gold standard, right? And this is why you want to think up front. Do you want org names, particularly if org names include people names? And I can't think off the fly, but there are many corporations where the corporation is the name of the founder. Do you want that included, and how do you want it tagged? Does it matter that it's tagged as an org or a person or not? It's totally fine maybe to run a tool, see the output, see these kind of problems, then go back to your annotation guidelines, update them to handle that case. But then you want to make sure anytime you change the annotation guidelines that you go back to your gold standard, because your gold standard needs to be in sync with those guidelines. Because otherwise now you're changing a moving target, and how can you fairly evaluate the tool if you're changing a tool? Plus, the other idea of this talk is you've got multiple tools. You wouldn't want to favor one tool, because then your scores are off, right? If I give credence to this tool labeling Emerson Collective as a true positive, am I then going to go to the other tool where the other tool picked out the pronouns and tool A didn't? Now you're in this race of how do you keep updating? So I would say, if you're not sure what to do and you want to kind of run the tool to kind of see what a sample output is, I think that's fine. But ultimately, define that annotation standard, annotation guideline, develop the gold data. Once it's gold data, that's your gold data. then run the tool and evaluate against that.
And what about gold standards, gold sets for specific industries like finance, legal, et cetera?
Yeah, totally right. And as I mentioned, we've got annotation guidelines that are, language specific, that are entity specific. I think it's totally fair to say, I'm going to evaluate, let's say, patent extraction. And so here's a set of patents where I've scored the patents, I've annotated them, and I've defined a patent gold standard. And it may be that what you extract for patents is different than what you extract from medical data. As I mentioned, more and more of the tools are having medical specific models. So their extraction for the regular model may not, may say, he had a cough and he took aspirin. So it might identify aspirin as some name, but it may leave out cough. I saw this with Comprehend when I was checking it out. So in the medical model, they'll extract cough and they'll tag cough as a symptom. So, it may be that my generic annotation guideline doesn't identify cough. And then in my medical specific guideline, I do identify cough, and I do identify how we tag medical symptoms, medical diagnoses, doctor's orders, medications, prescriptions, and stuff. So I think it's totally fair to have domain-specific annotation guidelines and then gold sets made off those guidelines.
Okay, do your entity extraction output feed into methods, tools for topic understanding, like language translation?
So specific to Rosette, our tools generally output JSON. So that can be incorporated into any other tool that can read JSON. We've got a REST endpoint that can take JSON in and output JSON out. We've got our own standard that we call ADM, the Annotated Data Model, that can give you a lot of information about the entity, the confidence that we extracted it, the entity ID tied to some database. We've got an, Java SDKs that will give you basically Java output. So you can write Java classes if you don't want to make HTTP calls. So the output of the Rosette tools are meant to be general enough that they can be incorporated into any other tool in whatever your NLP pipeline is. Now, I'll also say that we do have a topics endpoint where we use our own tools for extraction and then do an analysis where we can give you what the general topic of the text is. In addition to a categorization endpoint, and as I mentioned with ontology, we have a categorization endpoint that maps to the DBpedia types. So we do try to map to known standards, and we do try to have this general, fairly easy to ingest format that you can use for other tools.
Great, and sorry, we are running out of time, and we have 20 unanswered questions that there's no way we're going to get time to. If you didn't submit your question anonymously, we might be able to email you, an answer. So we'll start working to kind of sort through those questions. But thank you so much for everyone for joining us. I definitely hope you learned something while you were here and found this useful. As mentioned a few times already, there's a super quick 5-question survey. It should take you 1 minute to fill out. We would really appreciate you doing that. Check out our upcoming webinars at basistech.com/events, and stay safe and healthy out there. We hope to see you again on the next one. Thank you. Bye.